Water flows from a higher level to a lower level. But for this cycle to continue, water should be taken to the tank again. The sun provides this energy, creating a water cell. Now coming to a silicon solar cell. A silicon solar cell is made up of a lot of silicon atoms, a whole lot of them. When a red photon hits an electron in a crystalline silicon, the atom gets ionized. However, when a low energy infrared, microwave or a radio wave light falls on the crystal, it cannot be absorbed and the photon leaves the crystal. The sun emits radiation across most of the electromagnetic spectrum. It comprises of light of lower wavelength and higher energy to light of higher wavelength and lower energy. The sun's power can be considered as being delivered by sun soldiers of different energies. In a bulk semiconductor, when a high wavelength photon or a low energy sun soldier is directed towards the bulk silicon, we see that it cannot generate a photoelectron and it leaves the material without any work being done. The similar fate follows for an infrared photon or a soldier, as their energy is insufficient to raise the electron from the valence band to the conduction band. The energy of these soldiers remains unutilized. However, the red soldier, whose energy corresponds to the band gap, can contribute to the generation of photoelectron. The same follows for a yellow soldier, which has energy higher than the band gap and hence contributes to the power production in the solar cell. Now coming to the blue soldier, which has nearly twice the energy as the red one. Although this photon produces an electron-hole pair, these electrons are ejected with a much higher energy that it is converted into heat. So the solar cell misses out on a lot of energy. One possible solution for this could be by reducing the size of the crystal to a few atoms, to the size of a dot, well, something to the size of a quantum dot. Behavior is different when a low energy photon falls, because when an electron is excited, the void of the electron acts like a positive particle and hops across the lattice. The electron and the hole get attracted and unite like an atom, lowering the energy. And energy is not wasted. Quantum dot is a special class of semiconductor whose characteristic is closely related to the size of the individual crystal. So smaller the crystal gets, the larger the band gap. Changing the size leads to changing the band gap. So how does this help? Having quantum dots of different size is like having many semiconductors of different band gaps. In this way, we can exploit all of sun soldiers. In other words, effectively absorb the whole solar spectrum to produce more photoelectrons. Taking a bigger picture and comparing both the cases, it is clear that the quantum dots effectively absorb the entire solar spectrum, hence producing more photoelectrons and making the solar cells more efficient, and hence making this world a better and a greener place to live in.